The hose reel is an essential part of any modern arable farm. The technically advanced machines available today are highly controllable. An intelligent hose reel. Features include optimum ease of operation, optimum hydraulic efficiency, optimum mechanical reliability, and optimum electronic and mechanical control. Automatic trolley loading featuring anti-tilt mechanism with consistent height that is unaffected by slopes. Better reel safety. An automatic sensor bar protects against coil misalignment. Efficient turbine, versatile with wide flow passages that reduce stoppages and pressure loss. More reliable high winding-in speeds for very light applications. The transmission has a dual ratio gearbox for increased speed range. The automatic hose unwinding brake has been adapted to satisfy the widest range of water distribution. The vario-angle nozzle selection guarantees even distribution throughout the crop, making your pound work harder in today's fast-moving agricultural world. Reel machines are the obvious choice for increased irrigation efficiency, with every drop of water used to maximize your crop with very little wastage. At least, that's what the salesmen say. But real life is not like that. The day-to-day operation of a rain gun, whilst certainly better than no irrigation, is less than perfect. Damage to the crop whilst winding in is very common, a problem that's repeated over and over again throughout the season. Operating rain guns with even small amounts of wind results in huge variations of throw width. This is made worse with wind fluctuations during the winding-in process. With levels of distribution uniformity at best 65%, and taking into account wind drift and over-application, it's very easy to over-irrigate, with the resultant water piston effect pushing away from the rooting area all of the critical nutrients, especially nitrogen. The spaces between the soil particles lose oxygen and become filled with water. In effect, the soil reaches field capacity. The combination of these effects can very easily leave the plants looking less than 100%. The consistent cycle of overwatering and drying out often leaves the soil capped and cracked, exposing root crops to the direct sunlight. This can be particularly difficult to control with our variable and unreliable climate, leading to significant rainfall immediately following an irrigation application. As you can see from this independent data, small increases in wind speed have a significant effect on rain gun uniformity. This would not be a problem if wind speeds were uniform, but as they can constantly change throughout the day, so does the distribution pattern of the rain gun. It's unfeasible for users to constantly adjust the gun to get optimum performance. Therefore, users must settle for a very low uniformity figure across a multiple irrigation pool area. Revaho are able to offer a complete solution to all of these problems. A decade of experience has enabled us to produce a documentary of irrigation solutions. Micro sprinklers, drip irrigation, infrastructure, soil moisture monitoring. Field-scale micro sprinklers offer an affordable and extremely effective solution to irrigation inaccuracies. Using polyethylene pipe laterals up to 50 mm in diameter, we can cover in excess of 400 meters fed from one mains at the headland. A level of 85 to 90% Christensen uniformity is standard even in difficult topological terrain and in high levels of wind. Aiming for a typical hourly application rate of 3 mm per hour, this type of uniformity gives greater flexibility of operation, enabling the farmer to respond quickly and positively to the crop requirements. At the heart of the system lies the Super MAMCAD micro sprinkler. This is a low-cost, robust unit that features no exterior moving parts, no springs or levers to foul and cease over time. Inside the toughened casing lies a pressure compensation unit, swirl chamber, nozzle lever and stainless steel ball bearing. As water passes through the unit, the swivel chamber forces the water into a clockwise cyclone. This spinning water lifts the steel ball upwards to the nozzle lever until the ball hits and instantly loses its energy. Almost as instantaneous, the ball collects energy from the spinning water, and the process starts over again. The unit is kept watertight and operational by a series of seals and wiper seals. These also serve to keep dirt out. The critical part to this sprinkler, though, is the sculptured nozzle. It's designed to ensure that the water spray and overlap patterns are the best in the business. The sprinkler is the heart of the system, and the system is ideally designed to fit into today's farming procedures. The reel of lateral PE pipe, generally 40 or 50 millimeters outside diameter, is delivered wound on a steel drum, either 700 or 1000 meters length. At the start of each run, the PE pipe is trimmed and fitted to the compression fitting located on the mains. The mains can be existing pipework, either surface or underground. In this particular site, the farmer has also chosen computer control to minimize labor costs. At the end of the season, the lateral is uncoupled in the opposite way. The unwinding machine exactly matches the tractor speed to allow for a consistent and trouble-free unrolling. It also functions as a pulling-in machine at the end of the season. Revaho designs all systems individually, using computer-generated data to make recommendations for the sprinkler spacing, which is then repeated throughout the area or crop to be irrigated. For each sprinkler, a lateral adapter is pushed into a drilled hole. This will remain in situ for the lifetime of the pipe. The unit is flush and thoroughly secure. At the base of the feeder tube to the sprinkler unit is the male version of the lateral adapter that just clicks into place and remains there until the end of the season, when it is similarly easily removed. The sprinkler stake is pushed into the ground and the job is finished. All that remains is the system startup. With an emphasis on being low cost, manageable and very accurate, the Super MamCAD field scale sprinkler system is an option that can be easily fitted into any existing farm management practice, giving unimagined uniform crop results and offers labour and water savings of over 30%. Drip irrigation can be further subdivided into two categories: pressure-compensated reusable and disposable tapes. Revaho don't recommend the tape option for the following reasons. 1. The maximum run length of a tape is 200 meters. 2. Tapes cannot realistically handle any slopes above 2% downhill and practically 0% uphill. 3. They have to be buried, which can be awkward. 4. They are generally retrieved whilst harvesting and can get tangled up in the harvesting machinery. 5. The drippers are cruder and less effective because of their increased blockage potential. 6. In some wet years they may never even be used, but they still have to be pulled up and thrown away. 7. Because it's impractical to clean it for recycling, disposal of the used tape is difficult. Let's put it in the bin. Pressure-compensated systems. The Netafim ram drip line is placed in the furrow between two ridges. Both water and nutrients are fed down the 20 mm LDPE drip line and pass through the sophisticated pressure-compensated drippers. The water and nutrients are placed directly into the soil at an exceptionally uniform rate, completely unaffected by wind or evaporation. So, essentially everything you program to irrigate gets where you want it. To keep scab under control, the drip line maintains a level of moisture surrounding the sensitive area of the growing potato. Water and nutrients travel sideward by capillary action through the soil, essentially maintaining a high level of oxygen, giving the plant root system the perfect recipe for growth. At the heart of this system is, of course, the dripper. The Netafim ram dripper is the most sophisticated money can buy. The injection molded unit is the market leader. The method is deceptively simple. Water passes through a filter area at the entrance to the dripper and then through the engine of the dripper, the patented labyrinth. The critical design of the Netafim ram dripper ensures a large cross-sectional area so that any dirt can easily pass through and be ejected from the outlet. The positioning of the teeth in the labyrinth engineers a turbulent flow so that the water has a tough passage through the dripper. This stops any dirt or algae particles from settling on the sides of the dripper, ensuring a long life. Each ram dripper with the correct filtration and maintenance has a life expectancy in excess of 15 years. Each dripper has a rubber diaphragm inside sitting on top of the labyrinth. As the labyrinth pressure inside reduces, the line pressure inside the dripper is therefore lower than outside. Thus, the diaphragm is pushed downwards over the specially designed outlet hole. This action maintains the exact output within the pressure range. If dirt enters the dripper and tries to block its operation, the pressure inside the dripper will increase towards the line pressure. As this happens, the diaphragm becomes less concave and increases the passage to the outlet, and the dirt passes freely through. Field-scale drip is an extremely practical and adaptable operation. The drip line is delivered on steel drums, each containing 4,500 meters of Netafim ram. The handling machinery, as with the micro sprinklers, can double as a laying and a rewinding system. The empty reel is easily and quickly removed from the shaft of the laying machine. This whole procedure can be done by one man or a team of men, depending on the site requirements. The new reel is loaded, locked in place, the brake system connected, and then taken into the field. Depending on site labour, between 6 and 10 hectares can be laid within a normal day's operation. The use of larger machines allows up to 40 hectares to be laid a day. The work is not difficult and does not require any special skills. Revaho offers complete on-site training to ensure the maximum can be achieved within the shortest possible time. This training can be carried on throughout the following years as well. The ram is secured at the end of each row by wrapping the ram around a peg, then sliding on a figure of 8 end piece. The driver controls the pace of the unwinding to ensure a smooth operation. Speeds of up to 10 km per hour are normal, and 15 can be achieved if necessary. The pipework should be laid after planting when an appropriate window occurs. As one of the important operational rules is to maintain a level of moisture within the soil at all times, generally drip irrigation is commenced earlier than overhead. If the laying is left too late and prolonged drying does occur, then it can be wasteful and difficult to re-moisten the soil completely. The PE submain is generally 75 mm in 9 meter lengths with a quick coupling fitting for ease of use. Once the ram has been laid and connected, the lines are flushed of dirt particles accumulated during installation. The pressures checked throughout the system to ensure that all drippers are operating between 5 and 40 meters, and the system is then ready to work for the season. At certain times throughout the season, it's good practice to flush and check the pressure to ensure a maintained optimum through the growing season. All of the Revaho drip and micro systems can be built around existing common practices. The PE submains are designed to be driven over by tractors and sprayers. In fact, the whole idea of these micro and drip systems is that you have more time to produce higher quality crops with better management. One of the driving forces behind drip irrigation is the enormous savings in water that can be achieved. We suggest on average 50% water saving, because the application rates are so accurate. Water saving is only half the story. Fertilizer application is the key to successful drip irrigation. By applying them directly and accurately through the Netafim ram, you're applying up to 30% less nitrogen. Other advantages can include zero soil erosion with the subsequent less capping and cracking, significantly less botrytis and fungal infestation. Spraying programs are never interrupted as you can spray as you irrigate. Land is less wet, therefore harvesting will be earlier and easier in wet harvesting times. The temperature of the soil is higher, allowing for longer bulking periods at the end of the season when the outside temperatures are falling. And of course, the crop performs better. More of what you can sell means higher profits with lower costs, a critical combination in today's modern business. When the crop is ready, the system is removed prior to harvest. The submains are uncoupled and the ram drip line simply cut from the plastic connectors. The ram is now ready for collection. The combination unit which laid the ram is positioned in the collection mode, with the tension wheel allowing the pipe to be wound on the drum without tension, and the organizer allowing the pipe to be wound on as efficiently as in the factory. Maximum run lengths vary from field to field and soil type to soil type. The maximum we recommend is 250 meters from the headland. On fields greater than 250 meters, it's preferable to pull from both ends of the field. At the end of each line, a simple PE push-fit fitting is used to join the ram drip line together. This fitting gives a stronger finish than the pipe itself. At the end of each season, there will be 4,500 meters on each drum, ready to be stored for the winter, either inside or out, through all weather and temperatures. When the pipeline needs to be laid for next spring, it's completely immaterial what new run lengths there are. The ram is essentially 4,500 meters again and can be cut to suit year after year. Although the ram dripper line and the Super MamCAD are at the heart of these respective systems, it's also vital that the infrastructure of each system is well designed, robust, and totally suitable for the job. Filtration is an integral part of drip and micro sprinkler systems. Filters can vary from semi-automatic cleaning units to the latest generation of fully automatic self-cleaning filters, the Amiad SAF series, a range of epoxy-coated steel filters designed to match varying flow rates. The SAF filter offers the grower a low-maintenance, high-capacity filter system that's easily mobile, weighing only 150 kilograms. Unlike other filtration options available, the SAF does not waste high volumes of water during cleaning. Water enters the filter and passes through a coarse screen to remove large debris. The water then enters the center of the fine filtration screen, and as it passes through to exit the filter, any dirt is caught on the screen. When the filter senses it is blocking up, the cleaning cycle begins. The central shaft is hollow and has 3 orifices mounted on it. This is connected to an exhaust chamber. With this chamber opened, water tries to escape through the shaft orifices and out of the exhaust chamber. In doing so, the dirt is also sucked off the screen. A motor then turns the shaft on a worm and wheel so the entire screen area is cleaned. This filter can be used in conjunction with mains or battery power. Automatic control systems are commonly used, enabling precise irrigation and fertigation of multiple areas at the touch of just one switch. Fertilizer injection involves simple water-driven Amiad injection pumps, enabling precise injection of fertilizers direct into the system to maximize fertigation efficiency. Irrigation monitoring. Regardless of your irrigation method, reliable monitoring of soil moisture conditions is imperative for maximum irrigation efficiency. Using the latest in capacitance probe technology, Revaho can offer either manual read systems or computer-linked data collectors to enable on-farm monitoring of crop moisture levels. When monitoring, we recommend using 2 probes per site, one at tuber depth, 20 to 30 centimeters, and the other beyond normal root depth, 50 to 60 centimeters. When this data is graphed, we see that the shallower probe reacts to irrigation and rainfall. This data tells us when to start irrigation. The deeper probe ideally gives us an unchanging reading. If, however, the deeper probe starts to show a higher reading that can be related to irrigation, we know that irrigation is too heavy. Therefore, we're losing water and nutrients to excessive soil depths. Taking regular readings 2 or 3 times a week gives the grower the ability to be constantly topping up the soil moisture level with their drip or sprinkler system to keep plants growing at an optimum level. Whereas with mobile gun systems, more often than not, growers are chasing an ever-increasing moisture deficit. For Revaho, everything revolves around better results not merely for 1 or 2 seasons, but year after year. Revaho will lay a solid foundation for profitable operating results based on a combination of a thorough site analysis and evaluation of agri-economics to give you optimum yield from every square meter at the lowest possible cost. Revaho equipment is undoubtedly a sound investment.